Hello, Algebra 1 students. As we discovered yesterday, we're learning a little bit differently this week, but we are still learning. So I hope by now you've found your assigned seats and you have your notebooks out and you're ready to follow along in this video to take good notes with me. We will be testing over this material on Friday. So today's our last day of new stuff, and then we'll review tomorrow, test on Friday. So today's objective is to simplify square roots with imaginary numbers. The first part sounds familiar because we were simplifying square roots yesterday, so it's just the second part that will be new for us today. So let's start with a warm-up from yesterday. So to pick up where we were yesterday, why don't you make your factor trees for 88 and for 96. Pause the video to try these two on your own, and then we will compare. All right, so like we discovered yesterday, there are many different ways you can make your factor tree. For 88, I personally first thought of 8 times 11. 11's prime, but the 8 breaks down into 4 times 2, and then the 4 breaks down into 2 times 2. So there's our list of prime factors. If we look for our pairs and spares, the pair of 2's would go out. And then we still have this 2 times 11 that are unpaired, so we can just multiply those and keep them inside of the square root. So hopefully you tried that on your own and you got 2 times the square root of 22. For 96, that is a little bit bigger of a number, but I know it's even, so I can take half of that. So that's going to be 2 times 48. And then you could just keep going with that trend. 48's still even, so I'm going to take half of that. So that'll be 2 times 24. 24's even, so I'll take half of that, and it's, cross those out. That's 2 times 12, and 12's even, so I can take half of that as 2 times 6, and 6 is even, so I'll take half of that to get 2 times 3. Oh my, this is quite a long list of factors. Remember, we need pairs, so I have a pair of 2's, another pair of 2's, so I actually have 2 pairs of 2's, or 2 times 2, to give us 4 on the outside, and then we're left with just 2 times 3, so we're left with just 6 on the inside. So hopefully you tried that as well, and you got 2 times the square root of 6. So that was yesterday's lesson on simplifying square roots. Well, today we mentioned that we're going to use imaginary numbers. So remember the number system. You don't have to write this down. Just remember with me. When we made this number system at the probably first day of notes, so you can look back at day 1, remember over here on the big side, we said we're the real numbers. And over here on the much smaller side, we said we don't do a whole lot with them yet, but those were the imaginary numbers. And remember, I said a couple things. I said imaginary numbers could look one of 2 ways. It could be a number with the little I after it, or it was any square root with a negative number on the inside. So since we're talking about square roots, we're going to be doing square roots today, but with negatives inside. That's going to produce an imaginary number, which is going to make us need to use this letter I, or variable I, which stands for imaginary. So let me show you with an example or two what I'm talking about. So if you want to title this new section of your notes, Simplify Imaginary Square Roots. And then, like always, label your examples and write the original problem, please. So your notes are very neat and they'll be helpful for you to go back and study when you need to study for your test on Friday. All right, so the new part today is the fact that inside the square root, we have a negative. Remember, we talked about if you did that on a calculator, it would say error, right? Because your calculator doesn't do imaginary numbers. Well, for us, we're going to be able to indicate imaginary numbers with that letter I. So everything's going to be the same as what you already know. So things you already know would be that 49's perfect, right? Because it's 7 times 7. So if the square root of 49 is 7, then the square root of negative 49 just means it's going to be an imaginary 7. So we indicate that by writing 7i. And that's your answer. So that's what our answers will look like today. Since they're imaginary, they will all use that letter I. For example 2, it should look pretty similar because again, 16 is a perfect square. So that's one that we have memorized. It's 4 times 4. So the square root of 16 would just give you 4. Well, here, since we have the square root of negative 16, we know anytime we have a negative inside the square root, we have an imaginary number. So we would write that as 4i. Not so bad, right? So those first 2 examples dealt with perfect squares. Our next examples won't have perfect squares, but we'll still be able to do what we were doing yesterday. So 50 is not a perfect square, but just like we did yesterday, we can start breaking that into its factors. So I might think 50, I think about quarters, so that's 2 quarters, 25 times 2, and 25 is a perfect square, so there's my pair, 5 times 5. So just like yesterday, we take out the pairs, leaving the spare. So we'll take out the 5, but when we do, we also have to go back and remember there was that negative, which is going to make this imaginary. So it's not just 5, but it's 5i, and then we still leave that 2 right there. The 2 is still left inside of the square root. So your final answer, 5i square roots of 2. So it looks just like the problems we were doing yesterday. It's just the I that is the new part. And again, we only need that because we're taking the square root of a negative number. Not bad? All right. So what's the process? Start making your factor tree just like yesterday. So take a second to pause this video and see how you will factor 72. All right, so there's a lot of ways to do 72. Perhaps the easiest, so you could have done it differently than me, but one of my big mantras is to work smarter, not harder. So I know 72 is even, so I can take half of that. That would be 2 times 36. And lucky me, 36 is a perfect square. So I know that that's going to give me a pair of 6s, and I can stop there. If you watch the Delta Math help videos at all, you notice that this was always their method, to look for the biggest perfect square. Then you know that you found your largest pair of factors, and you can take those out. So we have a pair of 6s. We also had a negative, so it's not just going to be 6, but it's going to be imaginary, so we'll call that 6i. And then the only thing left inside the square root was this 2 again. So our final answer is 6i square roots of 2. Okay, so hopefully you get the idea. You see that it's very similar to yesterday. So again, take a second to pause and try the square root of negative 150. Again, a lot of ways to break down 150. Perhaps you thought about money. So if I have $1.50, I have 6 quarters. All right. So I like to use 25 because I know that's perfect. That's 5 times 5. 6 does factor, right? 6 is 2 times 3, but there's no more pairs. So the only pair we have was this pair of 5s. Again, because it was negative is why we'd have to use an I. So hopefully you tried this before me when the video was paused, and you got 5i. And then inside the square root, you still had 2 times 3, so you still have a 6 on the inside. Awesome. So our last examples are just a little special, right? This one, the square root of negative 5. There's not a whole lot we can do, right? Because 5 is prime, there's no factors besides 5 times 1, so making a factor tree wouldn't be useful here. So there's not a lot to do besides realize the fact that it's negative, so we know it's imaginary. So we can take out that I for imaginary, and then just write that as I times the square root of positive 5. So your homework is on Delta Math again tonight, and as I was looking through, I noticed some like these every once in a while. So just be aware, anytime there's a negative under the square root, it's an imaginary number, so you do take out the I, even if nothing inside the square root breaks down. So let's try one last example. Okay, so for this last example, we have, again, another negative, so we know it'll be another imaginary number, and the square root of 46. Well, 46 is even, so I can divide that by 2, so 46 will be 2 times 23, but then 23 is also prime, so we have no pairs, right? So if there are no pairs, we have nothing that can leave the square root. So 2 times 23 will just stay inside the square root again as 46. And the only thing we can do, because it was negative, we know it's imaginary, so we can pull out that I. So just be aware, even 46, that's a bigger number, and it does factor, but it doesn't have any pairs of factors. So not every square root is going to break down. So sometimes all we can do is realize that it's imaginary, so write the I on the outside and then write the square root of the positive number on the inside. So again, not super common, but maybe you'll run into one or two of those tonight as you practice your Delta Math assignment, so I just wanted you to be aware. All right, so speaking of which, it is assignment time. So you will open your computers, have your notes on hand if you need to refer to them. You should have scratch paper just because it's on your computer. Remember, you should be showing your work. Also remember your test on Friday, you cannot use a calculator. So get in the habit of showing your work, making your factor tree, circling your pairs, and doing all of this in your head. I know it's tempting, especially on Delta Math where there's a little calculator up there for you. Try to practice like the real test will be on Friday, and that'll be without a calculator. So log into Delta Math, please. You'll find your assignment that's called Imaginary Square Roots, and you have to do 10 problems to get your 100%. But if after those 10 you don't feel like you have a good grasp on it, of course, you're more than welcome to keep practicing. So please work hard and make it a great day.